All right, so in this video, we start section 7.5, which involves doing confidence intervals with bootstrapping, right? And there's going to be two main ways we do this. So pause, copy this first way down, and then press play. All right, so we've got two methods for using bootstrapping techniques to obtain confidence intervals. And I call this method zero because we're not going to actually use it that often, all right? So what we're going to do is we're going to do a T confidence interval like we did before. So this would be what, from section 7.1 method 2 or whatever, where we didn't have a normal distribution, but we approximated with a T distribution. So we're going to look at a T distribution confidence interval. And in section 7.1, to get that confidence interval, we needed to use S over root M, the sample deviation over the square root of n, all right? Now, the way we're going to adapt to using a bootstrapping technique is we're going to bootstrap the initial sample we have, that's what bootstrapping is, and we're going to calculate the standard error of that, all right? And we're going to use this standard error that we obtained from bootstrapping in place of S over root n in the T confidence interval formula. So from section 7.1, the T confidence interval was X bar plus or minus quantile times S over root n, where the quantile is from the T distribution. And we're going to replace that with X bar plus or minus the quantile times the standard error from bootstrapping, okay? So we're going to do the bootstrapping technique. We're just going to grab the standard error from it and plug it into the formula we had before. Now, this can be really good because there's some things that it's hard to calculate the standard error for, like median or trim mean, et cetera. And bootstrapping can just empirically calculate it for us. Okay. All right. So we will not use that technique too often. It's the next one on the next panel that we'll mostly be using. And note the different name, the subtly different name. This is the bootstrap T confidence interval, not the T confidence interval using bootstrap standard error, okay? So pause, copy. Okay, so here we're really going to use sort of the full power bootstrapping, okay? We're going to use a T statistic like theta hat minus theta over standard error. So in section 7.1, this was oftentimes X bar minus mu all over the deviant standard deviation divided by root n, okay? So we're going to use that same T statistic but we're going to estimate the actual distribution of the T statistic via bootstrapping rather than just assuming this T statistic follows the student T distribution, okay? And hopefully that'll become clear on the next panel through this example, okay? So we're going to go back to Bangladesh. And if you remember that data set, we had 271 wells, and they measured all kinds of levels of chemicals. We're just going to focus on the arsenic levels, okay? So we got 271 wells in Bangladesh, and we are seeking a confidence interval for the population mean of the arsenic level, mu, okay? Now, in section 7.1, our T statistic would be X bar minus mu all over S over root n, all right? And we would try and develop a confidence probability. 0.95 equals a probability that one number is less than or equal to this thing is less than or equal to another number, and then we try and solve for mu, okay? So, but there's a problem. In section 7.1, we kind of assumed that this statistic followed a T distribution. It's not a good assumption here, though, because if you remember that Bangladesh arsenic data was incredibly skewed. And if the original data is incredibly skewed, it's likely that this statistic based on that data is also going to be skewed. So it's probably not going to follow a student T distribution, right? And that should chime some bells with the assumptions that we listed at the end of section 7.1 about when we can safely use student T distribution and stuff, okay? All right, so we've got wells in Bangladesh, we've got a test statistic. We know it's probably not following the T distribution, so what do we do? Well, here is what we do. And at the end of this panel, I'll flip into R to show you sort of the commands or where you can find the commands and how R is actually doing this, okay? So pause, copy, play. All right, so here's the process of figuring out a bootstrap T confidence interval. The T is referring to the fact that we're using a T statistic. All right, we've got our original sample of 271 wells. We can calculate the sample mean, and eventually we're going to need to know the standard deviation of that original sample as well, which we'll call S. That crops up at the bottom. Okay. Now we're going to bootstrap it. So 10 to the fourth or 10 to the fifth times, we're going to resample 271 of these wells with replacement. So we might grab the same well 2 or 3 or more times, right? But we're going to do a resample of 271, and for that resample, we're going to compute the resample mean, X bar star, the resample standard deviation, S star, and then we're going to compute the resample T statistic. Now, I don't have mu, so I'm going to use X bar in place of mu. So I'm going to do the resample mean minus the original sample mean all over S star divided by root N. And I'm going to record this T statistic. I'm going to do this 10 to the fifth time. So I'll have 10 to the fifth of these values. And then that creates my bootstrap distribution of these values. Once I've got those 10 to the fifth values and its distribution plotted, I can grab the 2.5 and the 97.5 quantiles of that distribution if I wanted a 95% confidence interval, okay? So let's say I do that and I obtain negative 2.644 for the 2.5% quantile and 1.632 for the 97.5% quantile. What that is telling me is there's a 95% chance, approximately, because this is bootstrapping, that this T T statistic, and note I've got the population mean back in here, is between negative 2.644 and 1.632. Because remember, I'm ultimately after a confidence interval for the population mean mu. So I replace the bootstrap T statistic with the T statistic with the original sample versus the population mean, okay? And I then need to solve this thing for mu. So I do some algebra and I get this solved for mu. I have to multiply by a negative sign, so that's why the inequality, the values flip sides. So make sure you follow that algebra. And then that gives me the 95% bootstrap T confidence interval right there for the population mean, okay? So a somewhat involved process, and we'll do several, well, you'll do a lot of this for your homework and in class and stuff. Let me flip over to R and show you how it's going to get it. I'm sharing the wrong screen. R Studio, yeah. Okay. All right, so I'm on line 142 of the chapter 7 file. I got resample checked off, so my R knows what I mean by this data. I'm going to grab my arsenic data, and I'm going to take the mean of my original data and call that X bar on line 147. Okay. And if you want to know what it is, it's 125.3199, and here's the standard deviation, S, 297.9755, okay? And then I'm going to bootstrap this thing apparently 10 to the fourth time, so 10 to the fifth might take too long. And by the way, N is that 271 wells, and I'm going to create a vector to record my bootstrap T statistics, calling it T star on line 153. Okay, so now lines 155 through 159 is my actual bootstrapping. So first, I'm going to sample on line 157. I'm going to sample the arsenic data, size n, replacements allowed, and I'm going to call that new vector X. And then I'm going to calculate T star, which is the mean of X minus X bar, which is the sample, the original sample mean, all over the standard deviation of X. That's my S star divided by the square root of n, okay? So I'm going to evaluate that bootstrap simulation, and that's going to record 10 to the fourth values of that bootstrap T statistic. We got it. And then I'm going to ask for the quantile of that T star vector containing the 10 to the 4th values of the bootstrap T statistic. And I want the 0.025 and the 0.975. And there they are. And that's basically where I got my values. Okay, and what this is, these are a little bit different because it's a different simulation. But I got negative 2.67 and 1.69. Yeah, pretty close. And then I took those and brought them back to the board. Okay. And you can see that this T star distribution, this bootstrap distribution we got, isn't normal. Look at that plot. It's not aligned. If I throw a line in there to see how bad it is, it's bad. It's not normal. So just using the T distribution formula from section 7.1 would give us a bad confidence interval. Okay. And then here on line 169, I'm actually calculating the two bounds of the confidence intervals with the 97.5 and the 0.025. And if I run it, I get 94.7 to 173.8 as my confidence interval. Okay. And I don't quite know why the 97.5 and the 2.5 are where they are, but so be it. Okay, so you should start to get familiar with that code. All right, so one last panel to summarize what we've done here. So pause, copy, play. So in summary, for each of the 10 to the 4th or 10 to the 5th resamples, we're going to calculate this bootstrap T statistic, okay? All right, and then we're also going to calculate the Q1 hat and Q2 hat, the empirical, in other words, from the bootstrap distribution, alpha over 2 and 1 minus alpha over 2 quantiles of that, just of the distribution of those T stars. And then the bootstrap T confidence interval is our original sample mean minus the Q2 quantile times S over root n, and S is from the original sample, and X bar plus Q1 hat times S over root n, exactly as we did over there, okay? All right,